Alright, now I've said a lot of stuff in chapter 1 is foundational, and some of it I've been honest about we don't use as much as other ideas. But what we're going to do in this video, this is one of the most important ideas that you'll see in an algebra course, especially a beginning algebra course. It's called the distributive property, and I'm going to show you where it comes from. Okay, so obviously 3 times 5 is 15, right? Well, what if we split this up and we said 3 times 3 plus 2? Now, obviously this is still 5, and we would do that first, you would still get 15. Now, the distributive property says, look what happens. We're going to send the 3. So this is multiplication because they're times each other. I'm going to send the 3 to the first number, and I would get 9. I'm going to send the 3 and then multiply it by the back number as well, and that would be 6. So 3 times 3 is 9, 3 times 2 is 6. Okay, you put those together and you still get 15. Now, one example does not make a mathematical proof, but this is true. And so if we split up a number, so let's take a look at one. This has got an I don't know in it. But if we knew it, if we knew what x was, this is all one number, and we would get the same thing if we just multiplied the two numbers together or if we distribute. So the point I'm trying to make here is that it does work, and we can just send the 3 to both the first number, which would just be 3 times x. We can send the 3 to the 4, we'd get plus 12. Okay, so we'll do this again. We can send the 4 to the x, we get 4x. We can send the 4 to the 2, we get plus 8. Okay, once more. You can always pause the video if you want to. That gets me 6x. 42. Alright, now we can do this with fractions as well. So we just have to remember our fraction rules. I'm sending the 8 to both of those. So look how they've done this. 8 times 3/8. Remember, we could cancel down the 8's. We'd just be left with 3x. 8 times 1/4. You could do this several ways. I'm going to reduce it. Just get a 2 there. So 2 times 1 is 2. So I'll show this. We're really doing this. So those 6's would cancel. I'd have 5y. So those will reduce down, get a 3. So remember, I'll show you what we're doing here. Remember, we're doing this, putting everything along the top together. That's supposed to be a 3. Sorry, cancel those 2's. So that's the same thing, but they're both divisible by 2. It doesn't matter how you want to think of that, but we get a 3. Okay, we're distributing him again. Okay, so he's getting multiplied by both, so the 3, that would reduce. So we get 4n. This would reduce. You get 9. Now, I'm not showing the long way that we did in the earlier video, but it's the same. So go back and check that out if you're having any trouble, you don't understand what I'm doing here. I'm doing the faster way, but you could break it down into all the prime factors and do it that way. Okay, now we've got some decimals involved here, but that's no big deal. We know how to do that with 100. I'm going to send him to everybody. Now, if you multiply something by 100, it moves the decimal place 2 spots. We send the 100 to this guy, it moves that 2 spots, and we would get this. We're sending him here and here. So 2 spots would get me 70. Here, we get 15p. It moves that 2 spots. Okay, same. We're going there. First, we're going here. It'll move it 2 spots. I'll get a 4. Here, we move it 2 spots. We get 35d. Okay, so I'm going to distribute now. Now, the key on this one is the 2 owns that sign in front of him. So I'm not just sending through a 2. I'm sending through a negative 2. So it looks like this. A negative 2 is going through. So that's how I get down to this. Okay, so a negative 3 is going through. So I'm getting negative 18m. Negative 3 times 5 is negative 15. So now, because it was being added, I'm going to show that negative as being a subtraction sign, because there's this space between them, because it was being because we're dealing with addition. Okay, same thing, going here to here, and then to there. So negative 48n, now he goes there, gets me negative 66. So he's owning that sign in front of him. I'm going to show that negative 66 as if it was subtraction. Okay, let's do it again. I think, yeah, the only thing they're changing here is that's a negative 3 in there. I think that's the point. So negative 11 and 4 is negative 44. Negative 11, and now he owns that sign. So he's a negative 3. So negative 11 times negative 3 is a positive 33. And we're going to show it like it's addition because we had that gap there. I got to show that. Okay, let's go there and then there. So negative 5 times 2 is negative 10. Negative 5 times negative 3 is 15a. So it's two negatives make the positive, but I'm going to show the positive because we were dealing with addition or subtraction. Okay, so I've got negative 56 here. Go here. So the negative is coming further right. So negative 7 and negative 15. Everybody's going to own the sign in front of them. So we've got plus 105y. All right, now don't let this one confuse you. This is something students will miss quite often. This negative is like a negative 1. So I'm going to send this negative sign through as if he was a negative 1. And so I'd have negative y now, and negative 1 times 5 would be negative 5. Or you could think of it as opposite, as everything in there is being the opposite. But I think the negative 1's the better idea. So there's going there to there. Okay, so this is like a negative 1 going there, so I'd get negative z now. Negative 1 times negative 11 is now plus 11. Okay, so negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. Okay, so what are we doing here? So I have some cleaning up to do. So when we get to equations, we're going to see something like this quite often. This 2 has to be distributed through here, but it's not just a regular 2. He's going to own that negative sign. So I'm going to send through a negative 2. That's where they get this. Sending a negative 2 down here, I get negative 6. I'm going to show that negative as a subtraction sign. Okay, now we've distributed, but we've got some cleaning up to do. The 8 and the negative 6 are the same kind of thing. They're like terms, so I can put them together, and I get this. Okay, we're going to send a negative 3 through there. So we're doing the multiplication first, so this distributing has to come first. But it's not just a 3, it's a negative 3, so negative 3x. Negative 3 times 2 is negative 6. Okay, we have some like terms here. We can put the 9 and negative 6 together, so we get 3. Okay, send that down. So negative 5 is going through, so he makes negative 5x. I'm going to show that like subtraction. Negative 5 and 20 makes negative 20. Now my like terms are now over here. I've got people on the x team, so now I have 2 guys on the x team. I got 7, you owe me, or take away 5. Get down to that. Okay, they just keep getting more complicated, but it's the same idea. This is one that would really give students trouble, so I'm going to send the 4 through here. So we've got multiplication. I'm going to start with the one on the left. So I send him through. I get this. Now this is the negative 1 trick we saw. So a negative 1 going here makes it negative x. Negative 1 times 3 makes it negative 3. Now we've got some like terms. We've got some x's here, 4 and minus 1. We got some negative 32 minus 3. Okay, remember you can always pause it and try it. I think you probably are understanding here. Okay, 6 times x, and then 6 times it gets me negative 54. Now we've got the minus trick going on here. So I've got minus x minus 12. Okay, put those together, I get 5 x's. So I'm putting together the like terms. So negative 54, negative 12. So you owe me 54, you owe me 12 more. You're at negative 66. Going through here, we get 8x minus 8. Go through here, we get minus x minus 5. So remember that -1 trick. Now these are like terms. So I get 7x. Now putting these together, minus 8, minus 5, things are getting worse. Minus 13. Okay, now that's a brief introduction to the distributive property, but boy is it important. You're going to see that for the rest of your algebra career, so please make sure that that makes sense.